Hello and welcome back to SWA. Today we are diving into one of the mind-bending concepts in quantum physics, quantum entanglement. If you ever wondered how two particles can be connected in such a way that a state of one instantly influences the state of the other, no matter the distance between them. If you ever wondered how two particles can be connected in such a way that a state of one instantly influences the state of the other one, no matter the distance of between them, then you are in for a treat. This phenomenon challenges our everyday understanding of reality and continue to fascinate scientists around the world. So let's explore what quantum entanglement is and why it's so important. Quantum entanglement is a phenomenon where two particles become intertwined, shared states regardless of the distance separating them. What does that really mean? In the world of classical physics, the physics that governs the everyday object we see around us, objects and particles exist independently of one another's, and their properties are well defined. For instance, this is my phone. The height, the length, everything is well defined about it. To understand the quantum entanglement, we first need to briefly touch one of the principles of quantum mechanics, the branch of physics that deals with the behavior of particles that at smaller scales, like atoms and subatomic particles. So we are gonna talk about the physics doesn't work with these objects. Our scale will be less than nanometers. In quantum mechanics, particles like electrons or photons don't have a definite state until they are measured. Instead, they exist in a superposition of all possible states. For example, a photon might be in a state where it's simultaneously polarized in both vertically and horizontally. Imagine my phone could be this way and this way at the same time. It's only when we measure that it's choose one of these states. Let's simplify that. Imagine my phone is like this and this at the same time. Only in a condition where I'm not looking at it. It's good. It's both vertically and horizontally. But when I'm looking at it, it has to choose one of them, vertical or horizontal. In quantum physics, that's happening every day and one of the most important property of quantum physics. Now imagine that we have two particles that are entangled. This means their quantum states are linked, even if we separate them by great distance. If we measure the state of one particle, the other particle's state is instantly determined, no matter how far apart they are. This is quantum entanglement in action. So let's this phone again. This is my wallet. Imagine these two are become entangled. So they can be vertically, horizontally, but we have a condition. If I know this phone is horizontal, this wallet couldn't be horizontal anymore. So imagine I am closing my eyelids and these two particles are in superposition and entangled. So they both can be horizontal, vertical, and blah, 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 anything, any state possible. But, and it's important, I throw that wallet away. Sorry about that noise. So I open my eyes and see the phone chooses the vertical state. So my wallet is horizontal. Not important, I'm looking at them. Instantly, my wallet collapses in horizontal state. This is something I tried to simplify quantum entanglement. Until now, everything was normal. But we have paradox here. Quantum entanglement was first brought to the forefront of physics discussion by Albert Einstein, Boris Podolsky, and Nathan Rosen in 1935 in what's known as the EPR paradox. Einstein famously referred to the entanglement as a spooky action at a distance because it seems to violate the principle that nothing can travel faster than the speed of light, not even information. EPR paradox questioned whether quantum mechanics was a complete theory, suggesting that there might be hidden variables that we weren't accounting for. However, experiments over decades, particularly those inspired by John Bell's theorem, have shown that quantum entanglement is real and that no hidden variable can explain it in the context of classical physics. It's good to notice that quantum entanglement effect works in biology, and some of our principle in biology only works with quantum entanglement, like smelling and tasting. But some people says cognition or cognitions work with quantum entanglement. Photosynthesizes works with quantum entanglement. It's just good to notice that. So, how does quantum entanglement works? Let's consider a pair of entangled particles. When these particles are created, they share a quantum state. This means that the property of one particle are directly related to the properties of the other. For instance, if one particle has a spin pointing up, the other will have a spin pointing down. These pairs created in orbitals, one electron up, one electron down, we separate them. If nothing would be here to in environment to affect them, they stay entangled. The fascinating part is that the connection holds true even if the particles are separated by vast distance. If you measure the spin of one particle and find it to be up, the spin of the other particle will be instantly determined to be down, regardless of how far apart the particles are. This instantaneous connection defies our conventional understanding of space and time. When I'm talking about instantly, I'm literally mean instantly, not very fast. It's literally mean instantly. This is the important part. Quantum entanglement isn't just a curious phenomenon. It has profound implication for the future of technology and our understanding of the universe. One of the most promising applications of entanglement is in the field of the quantum computing. Quantum computers use qubits, which are quantum bits that can exist in multiple states simultaneously thanks to superposition and entanglement. This allows quantum computers to perform complex calculation much faster than classical computers. Another potential application is a quantum cryptography, where entanglement could be used to create ultra-secure communication channels, because any attempt to spy on an entangled communication would instantly change the state of the particle involved. It would be immediately detectable. Also, it has another potential application, quantum internet. If you are a gamer, you should know something called ping, which defined as a distance of you and server. With quantum entanglement and quantum internet, this ping always becomes zero. Quantum entanglement also raises deep philosophical questions about the nature of reality. If two entangled particles can influence each other instantaneously, What does that say about the concept of locality? The idea that objects are only influenced by their immediate. Some interpretation of quantum mechanics suggests that entanglement might imply that at a fundamental level, everything in the universe is interconnected in a way we don't yet fully understand. This leads to fascinating discussion about the nature of information, the fabric of space-time, and even the possibility of a multiverse. While these ideas are still largely theoretical, quantum entanglement continues to push the boundaries of our knowledge and challenges us to rethink the fundamental principle of physics. In conclusion, quantum entanglement is a captivating phenomenon that not only defies our classical understanding of the world, but also opens up new possibilities for technology and deepens our understanding of the universe. From its implication for quantum computing to its philosophical impact on the nature of reality, entanglement is a key concept that will continue to drive scientific exploration for years to come. If you find the secret of the universe by entanglement, you probably go to Switzerland and win a Nobel Prize. Thank you for joining me today to explore the mysterious world of the quantum entanglement. If you enjoyed this video, please like, share, and subscribe to SWA for more educational content. And as always, feel free to leave any questions or topic you'd like me to cover in comments below. Until next time, keep exploring and stay curious. Stay curious.